everyone, welcome to our YouTube channel, where we dive into the most mind-blowing mysteries of science that challenge how we see ourselves in reality. Today, we're tackling a question that might shake your worldview. Libet's experiments. Does free will exist, or is consciousness just an illusion? Imagine thinking you're in control of your choices, raising your hand, speaking, or going for a walk. But what if your brain has already made the decision and your consciousness is just along for the ride? In the 1980s, neuroscientist Benjamin Libet ran experiments that rocked science and philosophy, questioning the very idea of free will. We'll break down these studies step by step, explore their findings, critiques, and modern interpretations, including cutting-edge discoveries from 2025. Plus, you'll learn how to use this knowledge to better understand yourself and steer your decisions. Ready to explore the depths of your mind? Let's dive in. Let's start with what free will means. It's the idea that we consciously choose our actions, free from being fully dictated by external or internal causes. Philosophers have debated this for centuries. René Descartes argued the mind is an independent entity making choices, while Baruch Spinoza said freedom is about understanding the causes of our actions, not escaping them. In the 20th century, science took on the question, and Benjamin Libet, a neuroscientist at the University of California, San Francisco, made a breakthrough that forced everyone to rethink free will. In 1983, Libet published his groundbreaking experiments, now classics in neuroscience. His goal was to pinpoint when the brain forms a decision to act and what role consciousness plays. Participants sat in front of a device like a clock, an oscilloscope with a dot sweeping around a circle every 2.56 seconds. Their task was simple. At any moment they felt like it, move their finger or wrist, then note the exact position of the dot when they became aware of their urge to act. Meanwhile, Libet used electroencephalography, EEG, to measure brain activity, focusing on the readiness potential, RP, a faint electrical signal in the motor cortex that appears before voluntary movement. This signal comes from millions of neurons firing in sync, creating measurable electric fields. The results were jaw-dropping. The readiness potential appeared 300 to 500 milliseconds before participants reported awareness of their decision. For example, if someone noted they decided to move when the dot was at 12 o'clock, EEG showed the RP kicked in at 11:50. This meant the brain was preparing for action before consciousness made the choice. Libet went further. In another experiment, participants could veto their decision, stopping the movement at the last moment. The RP still appeared, but if they vetoed, no movement happened. This led Libet to a bold conclusion. Free will doesn't initiate actions but acts as an observer or controller, stepping in to approve or halt a process already underway. In other words, your brain hits the go button, and consciousness registers it, sometimes with the power to say no. These findings sparked a firestorm in the scientific community. If the brain decides before we're aware, what's left of free will? Determinists, like philosopher Daniel Dennett, saw this as proof that consciousness is a user illusion. Picture your brain as a computer, and you're the user thinking you're in charge, but the system's already running the code. Dennett likened consciousness to an interface creating a sense of control, while processes run automatically. Critics like philosopher Alfred Meller pointed out flaws in Libet's setup. First, the clock wasn't precise. Participants could misjudge the timing of their awareness by 50 to 100 milliseconds due to perceptual delays. Second, the RP isn't the decision itself, but a preparation, like warming up an engine before driving. Third, the task was too simple. Moving a finger doesn't reflect complex choices like picking a career or navigating moral dilemmas. In the 2000s, scientists revisited Libet's work with advanced tech. In 2008, John Dylan Haynes at the Max Planck Institute used functional MRI, fMRI, to track brain activity before a choice. Participants chose between pressing a left or right button, and brain activity in the prefrontal cortex and parietal areas predicted their choice 7 to 10 seconds before they were aware of it. This bolstered determinist arguments. If your brain knows your choice so far in advance, where's the freedom? But the 2010s brought counterpoints. Studies with implanted electrodes in epilepsy patients showed the RP doesn't always tie to a specific decision. It might reflect general readiness to act. In tasks involving creativity or moral reasoning, consciousness actively shaped outcomes, altering neural pathways. By 2025, neuroscience has leaped forward. A Nature Neuroscience study used AI to analyze brainwaves with unprecedented precision, revealing that the readiness potential isn't a rigid trigger, but a complex signal modulated by consciousness. Experiments at UC Berkeley showed experienced meditators could consciously suppress or amplify the RP, influencing decision timing. This suggests free will is a skill you can hone, like playing an instrument. A 2023 meta-analysis in Neuroscience and Biobehavioral Reviews found that in complex tasks, like ethical dilemmas or strategic planning, consciousness plays a pivotal role, reshaping subconscious signals into deliberate choices. Now let's explore the quantum angle. Roger Penrose and Stuart Hameroff's orchestrated objective reduction, ORC-OR theory, links free will to quantum processes in neuronal microtubules, tiny structures inside cells. They propose microtubules exist in quantum superpositions, introducing unpredictability. When these superpositions collapse, it adds randomness, making brain behavior less deterministic. A 2024 Physical Review study supported this, showing quantum fluctuations in neurons can influence network synchronization, creating wiggle room for free will. While ORC-OR remains controversial, it inspires researchers to bridge quantum physics and consciousness. Philosophically, this is thrilling. David Chalmers' Hard Problem of Consciousness asks why physical brain processes create subjective experience. Libet's experiments suggest consciousness is a delayed narrative, a story the brain tells itself to feel unified. But this doesn't make it useless. Evolutionarily, consciousness is valuable for planning, reflecting, and adapting. Think of the brain as an orchestra. Subconscious processes are musicians playing biological notes, while consciousness is the conductor guiding the performance without writing the score. Philosopher Sam Harris, a free will skeptic, says, "You're not the author of your thoughts, but you can be their editor." This echoes Libet's veto idea. Even if the subconscious starts the action, you can stop it. What's new in 2025? A Journal of Cognitive Neuroscience study used neural interfaces like Neuralink to track decisions in real time. Participants with implanted electrodes could intercept the RP, consciously altering actions. This confirms consciousness isn't passive, it actively shapes processes. Max Planck Institute research showed meditators increased RP control by 20 to 30%, literally strengthening free will. A 2025 Scientific Reports article described how chaotic neural networks in the prefrontal cortex create windows of freedom where choices aren't fully predetermined, supporting the idea that will emerges from order and chaos. Practically, Libet's work reshapes how we live. First, it boosts mindfulness. If the subconscious kicks off actions, training awareness, like in meditation, lets you notice and manage impulses. Try it. Sit for 5 minutes, close your eyes, observe thoughts without reacting. This strengthens the prefrontal cortex, enhancing control. Harvard studies from 2023 show 8 weeks of meditation increase gray matter density in this area by 5%. Second, it informs learning. In business and sports, pre-conscious training automates actions with conscious oversight. Athletes visualize movements to reinforce neural pathways, as in Libet's veto experiments. A 2025 Journal of Sports Sciences study found visualization improves movement accuracy by 15% by activating the motor cortex. Third, ethics. If will is partly an illusion, how do we judge actions? Neuroscientists like David Eagleman suggest focusing on prevention over blame, using education and neurotech. A 2024 Nature Human Behavior study showed neurofeedback reduced impulsive behavior by 30%. Quantum perspectives add intrigue. Penrose and Hameroff's theory suggests microtubules create indeterminacy, giving space for freedom. A 2025 Quantum Report study found quantum effects in neural cultures enhance synchronization, supporting the idea that will emerges from complex systems. This aligns with existentialist philosophy. Even if causes limit us, We're free in how we interpret actions. How can you apply this? Start with mindfulness meditation. 10 minutes daily, focus on breathing, 5 seconds in, 5 out, noticing impulses without acting. This boosts brainwave coherence, per HeartMath studies. Keep a decision journal. Write why you made choices to increase awareness by 25%, per Journal of Positive Psychology. Visualize goals to tune your brain, as in sports psychology. Surround yourself with inspiring people. Their energy syncs your neural networks, strengthening will. Avoid overload. 2025 Neuroscience Letters research shows stress reduces, or P control, making choices more automatic. Leibniz experiments don't destroy free will. They redefine it as a dance between subconscious and conscious, where you can become a better choreographer. It's a challenge. Observe your mind, train awareness, and steer your life. Are you a spectator or a director? You decide. Thanks for joining us on this deep dive. If this sparked your curiosity, hit that like button, subscribe, and share your thoughts in the comments. Do you believe in free will, or is consciousness an illusion?